So again, this is the marginal supply, meaning the derivative of the supply function. We are told that this is measured in units and X is the price per unit. This is the function. They are giving us that S of 5 equals 121. When the price is 5, the supply is 121 units. They're asking us to find the function. Good. So let's start. 0.24. Which function prime is x squared?
X cubed times 3.
Very good. Plus 4. Which function prime is x?
X squared over 2.
Awesome. Plus, which function prime is 10?
X.
Awesome. Plus, I can never forget a constant c. Perfect. Now we are using the information, the initial condition. S is 121 when x is 5. I will simplify here. 24 divided by 3 is 8 times 5 to the third plus 4 divided by 2 is 2 times 5 squared plus 10 times 5, which is 50, plus a constant c. From this equation, I will solve for c and plug it in. That's all I needed to do. So I'm going to write it, but then put everything in the graphing calculator. So c equals 121 minus 0.05 times 5 cubed plus 2 times 25, 50 plus 50, 100. Of course, everything is negative because this is moved, this is moved, this is moved, right? So 121 minus this, minus this, minus this. So now I'm going to share and go to the calculator. And we have 121 minus 0.08 times 125, that's 5 to the third, minus 100.
Professor, you wrote 120 instead of 121.
I did. Thank you so much. Thank you. I did write 120. Thank you. Good. So 11. So C equals 11. Thank you very much. So therefore, the supply function is 0.08 x cubed plus 2 x squared plus 10x plus 11. So let's write it. So S of x equals 0.08 x cubed plus 2x squared plus 10x plus 11. That's all we were asked to determine. Now, finally, let's talk about that symbol. Okay. So we know now that I never start in my STEM class, I never start with this symbol at the beginning, but this is how the book is presenting, so I'm going to stick with this. Okay. So when I have to explain, I can't just give you the symbol. So let's say this is the velocity function. And if I want to determine the distance between, let's say, 0 hours and 10 hours, all I need to do is look between 0 and 10 and calculate this area. Area under the graph of the velocity of the derivative function. If I manage somehow to determine this area, that will give me the distance between 0 and 10. If I want the distance between 0 and 12, then I need to find this area. And I will find the distance covered by the vehicle or particle between 0 hours and 12 hours, or 0 minutes and 12 minutes. So we're going to see in the next section how this area is calculated. Okay, so this will be in section 4.2. I needed to explain this a little bit before I use that symbol. So when we calculate these areas, we will calculate the area of this rectangle, then we'll calculate the area of this rectangle, and then another rectangle, and then the next rectangle, and the next rectangle. So this will be a sum of areas of rectangles. So this is a sum. And again, we're going to get to details in 4.2. Why do I need this? Because I just don't want to throw a symbol at you. So this sum of areas of rectangles is signified by S, the letter S from sum, but stretched. So instead of writing it like this, we're going to write it like this. It still says sum. It still represents the lowercase s. It still represents a sum of rectangles. But this symbol is called an integral. The integral symbol. The integral symbol, or the integral in general, we have two different types. Two types of integrals. Number one, the one that I just discussed, which we are not going to discuss right now, it's called the definite integral. I hope we get to it today, but maybe we'll see in a moment. So that's a definite integral, and this is the area, which we will discuss in detail in 4.2. The second type is indefinite integral, which is not an area. So the area is a number. The indefinite integral, what is it? And I'm going to use it right now. The indefinite integral represents a family of functions. What family of functions? Okay. We'll go back to what we just determined here. So if we are given the function 30x squared plus 5x plus e to the x, and we also have its derivative, which was 60x plus 5 plus e to the x. We are using this indefinite integral symbol from this function, from the derivative, this function. Something is missing, which is extremely important. It has to be dx. Notice that this is the derivative. This is the differential, right? It's dy, the differential. That's why we discussed it before. And the answer will be this. 30x squared plus 5x plus e to the x plus a constant c. So we may be asked to find the antiderivative of this, or we may be asked to find the indefinite integral of this, and we still get the same thing. So we may be asked to find the function. Either we are given the derivative, find the function, or We may be asked, find the indefinite integral of the differential f prime dx, f prime dx. From the differential of this, and we get the same answer. So there are two different ways of defining the same thing. The easiest one was this. Maybe you want to say this is slightly more difficult. I have to use the symbol, the integral symbol. I have to use the differential of x because this is dy, and then I get the answer. But we have to practice with both. First one we just did a few minutes ago. That was the easier if you want. But now we have to use this symbol, which is the indefinite integral symbol. And as you see, it's a family of functions. Many functions whose derivative is this. Okay, a family of functions whose derivative is this. Many functions have the same derivative. Now, with that information, we can choose any problem you feel like it, working on anything, from 5 through 46. They're all the same. They're all asking us to find the same thing. They're giving us the derivative, in other words, without telling us it's the derivative, and they're asking us to integrate. Find the indefinite integral. And then we'll look. Yes, I'm ready. Which one?
Sorry, can we do number 7?
Yes, let's start with number 7, and that's on page 392. Perfect example because this is what we just did, so it's a very good start. Thank you. X squared plus x minus 1 dx. Now, I want to caution you again, like with the limit, right, we had a long time ago, this symbol does not exist without dx or dy, dt, whatever. So please do not write this symbol without dx. If variable is x, if the variable is t, then you have to write dt. If the variable is y, then you have to write dy. So this symbol does not exist without dx. Good. So like before, nothing changed. Which function prime is x squared?
X cubed over 3.
Very good. Plus, which function prime is x?
X squared over 2.
Which function prime is negative 1?
1x.
Yes, negative x plus a constant c. That's it. Done. Next one. Let's choose anything else. Anything you want to work on.
Can we do number?
Any number. You can say more than one number, of course.
Number 14.
Okay, number 14. And which other number you wanted to pick?
Number 10, please.
Okay, very good. And number 10. Good. Perfect. So let's start with number 10. Good. In number 10, same page, 392, we have the indefinite integral of 3t squared minus 4t plus 7 dt. Perfect. Don't forget the integral has to have a d something. Good. 3. Can anyone give us what function prime is t squared?
T to the third over 3.
Very good. Minus 4. Which function prime is t?
T squared over 2
Good. Which function prime is 7?
is 7x.
T plus a constant c. Yes, I have to simplify these two. And I have to rewrite it as t cubed minus 2t squared plus 7t plus c. Done. Let's look at 14. That's all we need to do. To find the antiderivative, the most general antiderivative, or the family of functions that all have same derivative. Okay, and we said 14. Where are you? 14. Very good. 14. Same page. So the indefinite integral from the 7th root of x dx. Perfect. Good. If we don't remember how to change this into a power, then we get stuck. So the seventh root is the same with x to which power?
1/7.
1/7 dx. Good. Same thing, everything the same, plus a constant c. X to which power over what number? You don't have to calculate it. Tell us what you want to write first, and then we can calculate it later.
One seventh plus one.
That's it. Over the same number. Awesome. So this is 8 plus 1, 7 plus 1, which is 8. So this is x to 8/7 over 8/7 plus a constant c, and I have to flip the denominator. 7/8, x to 8/7 plus a constant c. Now tell me if we had enough. Let's also look at an exponential. Let's look at, I don't know, 28. So we have 4e to 4x dx. Good. Okay, 4 stays outside like always. A limit or derivative or integration, all are the same. But now we discussed this a few minutes ago when you picked another problem. Which function prime will be e to 4x?
E to the 4x over 4.
E to the 4x over 4, and we simplify and we're done. Very good. What if I had here 5? What would you have written here? 5 here, 5 here. What if I had -3? -3 over -3.